In this video, we're going to cover section 2.4, which is higher degree polynomial equations. We're going to learn how to solve some more equations that are not just our quadratics. We're going to solve equations that are similar to quadratics or that we can modify to make them as if they are quadratics. We're going to solve just general polynomials by factoring. And we're going to solve polynomial-like equations, meaning they're not polynomials because they have fractional exponents, but we're going to also do that using the same techniques as we solve polynomials with. So, discuss. So, an equation is going to be quadratic-like or in quadratic form if it can be written like a quadratic, except instead of having the variable parts of our normal quadratic, there's going to be an entire expression inside that variable part. The way we solve these, though, is we just replace that more complex piece with a single variable. This is called substitution. And then we can solve for that single variable we've created using our quadratic methods. And then finally solve for our substitution. Okay. For other polynomials or polynomial-like equations, we're going to use the techniques we learned earlier, which is going to be factoring. We can factor out the greatest common factor, or we can factor by grouping. Just remember that we solve by factoring, we are going to use the zero factor property. And so our equation needs to be set equal to 0. Let's look at some examples and I'll take you through this. So our first example is a 4th degree equation, but you might already notice it does look a lot like a quadratic. Basically, all our x terms are now x squared terms. So here we can just use substitution, and we can say let y equal x squared. Then when we rewrite our equation, we end up with a y squared minus 7y minus 144 equals 0. So because we let y equal our x squared, then this x to the 4th just becomes a y squared. All right. Now we actually do have a quadratic and we can solve this guy. All right. So first step to solving quadratics, let's just see if we can factor, right? We need a number that adds to -7 and multiplies to 144. Okay, that's going to be, let's see, what multiplies to 144? So 9 and 16 multiply to 144, and positive 9 plus -16 adds to -7. So we can factor this quadratic just like this, and I've already made the first mistake. The variable we are using here is our y. All right, so that we're solving our equation in terms of y right now, but remember, the actual equation is in terms of x, and so we have to make sure we get back to that. But we can say that now our y is equal to -9. That's the solution, or y could be equal to a positive 16. Both of these things solve this equation in terms of y. But we actually want our equation in terms of x, and we know that y equals x squared. So y can be -9 or y can be 16. So let's solve those. If y is -9, then we have that -9 is equal to x squared. And to solve this guy, we are just going to take the square root of both sides using our square root property, and we'll get that x is equal to plus or minus 3 I, right? Because we're taking the square root of a negative number, so we've got that imaginary piece. So that's one possibility. But we also have that y could be 16. So we have that x squared equals 16. Right? If that's the case, we'll square root both sides and we get a plus or minus 4. All right, so we have this fourth degree equation and we end up with 4 solutions. We've got plus 3i, minus 3i, plus 4, minus 4. But we solved it using just quadratic technique and substitution. But just don't forget, once you've solved for y is something we made up to equal x squared. You have to go back and solve for that x squared. Okay, so that's how substitution works. We just substituted out the x squared for a single variable y, which allowed us to use quadratic methods, but then we have to substitute back so that we figure out what x is. Okay, that substitution. Let's do a different type of problem. So here we've got y to the third plus 25y minus 3y squared minus 75 equals 0. And here we actually are solving for y, okay? So we've got a third degree equation. So substituting like we did before is not going to work because we've got a y to the third, a y, and a y squared. What we have are 4 different terms, 4 unlike terms. Notice, however, that I did already write them out of descending order of degree. And that's because when you have 4 terms like this, you want to try to factor by grouping. Okay, so I've already kind of got the first 2 terms, the second 2 terms. Let's just see if we can group them like that. So we look for what's common, a common factor in our first 2 terms and a common factor in our last 2 terms. Our first 2 terms both share a factor of y, so we can pull that factor of y out of our first 2 terms. All right, and notice how I changed this subtraction to addition so that I can say that both of my terms are negative. Okay. And then our second 2 terms, they both share a factor of 3, actually of negative 3. This is a plus over here, not to confuse you. So we've got y times y squared plus 25 as our first term with those 2 factors. And we've got negative 3 times y squared plus 25 as our second term with those 2 factors. So our similar factors are the y squared plus 25. So we can pull that off of our 2 terms. So we've got a y squared plus 25 that is in common with them. And then we've got a y minus 3 that is left. Okay. We can see that now we have these 2 factors and we can use the 0 factor property. You can see pretty easily that if y is 3, that will be one solution to our equation. And then if you want, you can take this other piece, y squared plus 25, and set it equal to 0. And if we solve that, we're going to get that y equals 5, or y could equal negative 5. So we have these 3 solutions to our third degree equation. And we did that just by factoring by grouping and using the 0 factor property. Right. So again, if it looks like a quadratic except slightly different, then use substitution. if it does not look like a quadratic. So in this case, it doesn't look like a quadratic because first of all, we have 3 variable terms. We have 4 terms total. So it doesn't look like a quadratic. Also, this is a 3rd degree, so it's not a multiple of 2. Try to factor by grouping. Okay. Let's go to our next example. So this next example is not actually a polynomial because the exponents on our variables are fractional. But we can treat it like a polynomial. We can actually treat it like a quadratic by using our substitution. So I want you to notice that our x to the 2/3 is the same thing as x squared times x to the 1/3. Excuse me, it's x to the 2/3 is equal to x to the 1/3 squared. Okay, so we can substitute out x to the 1/3 with another single variable, and that will make this equation look like a quadratic. So we will have our x to the 1/3 equal y. And then we are going to get y, x to the 2/3 is really just our y squared. So this first term becomes y squared. Our second term becomes minus 2y. And our constant term and everything else is the same. Again, we've got a quadratic here that we can solve. We just need 2 numbers. They have to multiply to -8 and add to -2. And that's going to be a 2 and a 4. Let's see, we're going to have a -4 and a +2. So y plus 2 times y minus 4. And then we know that our y equals -2 or +4. Don't forget, go back and substitute in. So that means x to the 1/3 equals -2 and x to the 1/3 equals 4. If we want to figure out what x is, we have to raise these to the 3rd power. So we are going to get that x is -8, because that's what -2 to the 3rd power is. And that x is 4 to the 3rd power. I believe is 64. Right? All right, so we've got these 2 solutions here. X is either -8 or 64. And it's always a good idea when you use this substitution to go back and check your answers. I'm not going to do that here, but I suggest you check your answers just to make sure that you haven't introduced any false solutions. Okay. I think we have one more example. And that is going to be 3x to the 4th plus 18x to the 3rd minus 21x squared equals 0. Again, we have 3 terms, but this is not going to be quadratic-like because we've got a 4th degree, a 3rd degree, and a 2nd degree. So our substitution is never going to get us to look like a quadratic. What we do have, though, and we should always look for first to simplify anything, is do we have a greatest common factor that we can remove? I believe that each term is a multiple of 3, and each term has 2 factors of x. So we can pull off an 3x squared. And what we're left with is x squared plus 6x minus 7 equals 0. Okay. So now keep in mind that this 3x squared is one of our factors. Using the 0 factor property, we can see that if x equals 0, our equation equals 0. So we already have one solution, that x equals 0. And that's because this factor right here, what makes this factor equal to 0? Well, that's when x equals 0. But here we have a quadratic, which is going to have two factors in it. So let's factor this and use our zero factor property again. So what are two numbers that multiply to -7 and add to +6? That's going to be x minus 1 and x plus 7. So we have that x, we can see right here, x can be +1 and x can be -7. All right. So that wasn't a quadratic equation, it's a fourth degree equation, but we can factor it, and then a piece of it will be a quadratic, which we will factor some more to get our solutions. Now notice we have a fourth degree equation here. Usually we want to look for 4 solutions, but when we look at our 4 factors, we have a factor, this x plus 7, we have this x minus 1, and then there are 2 factors here, two variables, 2 x's, they're both 0. Okay. All right, so that is solving, that's 2.4. That's solving these other higher degree equations that are not necessarily quadratics, but we can use a lot of our quadratic techniques, and we're definitely going to use factoring.